Hello, Scott. Hello.
Can you hear me, Raj?
I can hear you now. How are you?
Good. How are you?
Yeah, I'm good too. Thank you. So I'll make you the host for this workshop, Scott, so that you can share your screen or any question the audience might have. So you will just take ownership of this session.
Okay. That's good. Sounds good. Thank you. Thank you.
No problem. Let's see how many. Yeah. So I'll make you host. Then you can take over from there.
Okay. Okay.
Yeah. Okay.
And coming in is are you have a waiting room or are we coming in as right away?
Yeah, I just added you as a host. I can hear some repeated voice from your side.
You're hearing an echo?
Yeah, I'm hearing some echo.
All right. Let me change.
How's this? Is this better?
Yeah, it's much better and cleaner.
Okay. All right. Good. Switched over my microphone.
Yep.
All right.
So I'll just quickly check the Meetup page and Eventbrite and Facebook pages and see whether anyone has any question or anything. I already shared the invitation links to the people through email, so I'm hoping they will join. So give a few more minutes to them. So yep, I think one guy already joined.
Yep, we have one person connecting. Let me actually start. My presentation. All right. And people see my screen?
Yeah, I can see your screen.
All right.
Just for your information, Scott, this session is booked for 2 to 3 p.m. for an hour.
Okay, yeah, I have my presentation is probably about 35 minutes, and then we can have discussions after as well.
Okay, that's perfectly fine. I should have made it more longer, but I was just checking my Zoom that it's not allowing me to increase the time. So for this session, we need to continue for 3 p.m. But next one, I'll increase half an hour from next time.
Okay, all right. Let me see if I get other people. I only have 3 people at this point.
So we have total 10 people sign up for today's session.
All right. Now, when you're presenting, I usually use a round, but in Zoom, it should pop up as people are coming into the waiting room, even when you're presenting, correct?
Yeah, it will come up like that.
All right. Make sure. How is the weather in London?
Yeah, it's very beautiful. A lot of sunshine. Like you feel very hot. Like from yesterday. It's nice weather.
We've been bouncing back and forth with hot weather and cool weather as we transition
Yeah.
on the East Coast of the US.
So which part of East Coast are you from?
So I'm in the New England area. I'm in one of the states called Rhode Island, which is one of the it actually is the smallest state in the United States, just south of Boston.
Yeah, I know, it's beautiful weather, right?
Oh yeah, it's funny when New England we can get, you know, in May and the beginning of June we get hot days up into 95 degrees Fahrenheit, and then it'll drop down 30 degrees the next day. So
it's unpredictable.
Oh yes.
Yeah, like we wish this weather lasts for longer in London, but it's also a bit of like couple of weeks. It's a bit of predictable, but then it's completely unpredictable.
Yeah, it's difficult as the transition.
Yeah.
From the different seasons.
Yeah.
All right. I don't see anybody else popping in. Let me just stop to make sure there's nobody in the waiting room.
So in your participants menu, probably you'll see if people are in waiting, you'll see them in the waiting list.
Yeah, I don't see anybody else. I see Alphonse, and that's it. Sunday afternoons, especially on a nice day, it's tough to be inside, I guess.
You have to be inside.
So do you want to, should we wait a few more or?
I think let's give a 2 to 3 minutes more.
Okay.
Maybe people are enjoying the sunshine.
Probably.
Yeah.
Got to plan around those rainy days.
Yeah, and he's struggling to connect to the Wi-Fi, you know, going to the cities. Yeah. We did a good of a promotion for this session, like through LinkedIn. I think Manning's publications did some promotion. I did from my side, from Eventbrite's, Meetup, Facebook, LinkedIn. Let's see how it's going on. But
okay.
Some sessions you will see like this. Some people will join, very limited people join, but other sessions more people will be joining. So it's kind of your weather, like unpredictable. We don't know.
Well, somebody gets a one-on-one presentation. That's always a beneficial to that person who wants to join.
Yeah, exactly. Exactly.
Oh, yeah, we got somebody coming in. Welcome. We'll be starting just shortly, just seeing if anybody, some other people come straggling in.
Yeah, that's probably fine. So Scott, I will be making it live on Facebook. Okay. So in case anyone wants to join. So in that case, very briefly, I'll take the ownership of the host, and then I'll share on the Facebook, then I'll give you back. Okay.
Okay. All right.
Thank you.
So people that have joined us, do you have any exposure to cross-platform frameworks? And if so, which ones? If you want to just shout them out in the chat, just so I have an idea of where people are coming from when I start the presentation.
Yeah, from my side, it's called I have experience working with the Xamarin, okay? And mainly Xamarin platform I worked for building like iOS and Android app. I had some exposure on React Native, but and briefly I looked into Flutter, some sample projects. That all I have, but I didn't look that much in depth on the Flutter projects.
Okay, yeah, I actually worked with Xamarin just as Microsoft was buying them back in what, 2017. So I have my background. I've done before doing more mobile. I was doing web and desktop development, and a lot of it was in the Microsoft framework.
Yeah, it is like, I don't know how do you fill up that framework, but I found it's very difficult to work on that framework, especially when you do some comment tools development or when you do navigation. It's not that easy in Xamarin. And when you create the packages, development packages, it's also not that, small sizes, massively big sizes. And if you run that environment in your machine, you have to have that good machine with a lot of RAM and CPU power.
Oh yeah, well, even a lot of the cross platforms, you need a good, powerful system. But exactly. Yeah, it was a lot of with Xamarin, people were running into memory leaks because they weren't understanding the reference counters with working with iOS in the beginning stages, and people would run into challenges of a lot of memory leaks in their code with Xamarin. XAML, yep, when it first came out was pretty decent, but I haven't worked with it that much lately, so I know they made a lot of performance improvements with XAML on that. A lot of enterprises still utilize that.
Yep.
So it's been 11 minutes.
Yeah, so you can start. So I'll just very briefly, I'll take the ownership, then I'll make it live on Facebook, then we can go straight, okay? I'll very quickly take the, reclaim the host very quickly.
Okay.
Yeah. Okay, let me share on Facebook. Yeah, I have just done, just a second. Yep, so I already made the event live on Facebook. So Scott, you can now take over from your side. Thank you.
Okay, let me share my screen. All right. Everybody can see my screen. And let me.
Yep.
Sure, I get the chat window up. All right. Well, I want to thank people for coming, and Raj, thank you for inviting me to this presentation. So I'm going to cover Flutter, but also with respect to how it interacts with other cross-platform frameworks that are out there. And we're going to kind of involve step by step. So some things will be a little technical. I'll try to make it more abstract, just to understand what the frameworks are doing out there. And then we'll dive a little bit into Flutter not getting into really coding with Flutter, but getting an understanding of the framework. You'll see some screenshots of code just as you can do a comparison. And I'll use references back to such as Xamarin or React and React Native for comparison with this framework compared to others. So to get started, who am I? I've been a mobile developer for the last several years, dealing a lot of times mostly with cross-platform development. Before that, I did a lot of desktop and web full stack development. Lately in 2008, I got involved with Flutter development, and from there evolved and got reached out by Banning Publication to do a video course. So I completed that. That course currently is still based on Flutter 1.x. There's a new version of Flutter 2.x, so that course actually still probably needs some updates, and I'm working on trying to get some time to do that. Currently now, I work for a company called Super Formula. So Super Formula is a custom development shop. We have made the decision and focus stroke for cross-platform development on Flutter, using Flutter only. So our experience right now is, if you're familiar with MGM Resorts, their mobile app, we actually have designed and developed that with Flutter out there. So all the access to getting access to the rooms through opening of the doors, getting into the parking garage, making reservations and so forth. We built an application utilizing Flutter for the front end. So enough about me. Let's talk about what we're going to cover. Again, we'll kind of briefly talk about native and cross-platform and when to choose one or the other. I'll kind of break into what the different types of frameworks that are out there. I can't cover them all. There's quite a few, so I'll try to stick with some of the popular ones. Getting a little bit of the Flutter architecture and how the framework is built. And then we'll start getting into a little bit of detail with Flutter and how you work with it. But again, I'm not going to be running and building code, but it's more of a technical presentation, but I promise not to bore you with screens of text. There are going to be more screens of graphics and animations. So hopefully with the Zoom transitions, things will run smoothly. So the biggest question comes into place is, should you use cross-platform frameworks? And a lot of times the dreaded word is, it depends. It depends on your team, depends on your resources, depends on what you want to build. There's a lot of people that think about cross-platform as you have to be native. And as cross-platform frameworks have come about, they've actually improved. And so there's a lot of scenarios where you can do a lot of business applications easily with a cross-platform framework. You can actually do a commercial product like MGM with Flutter. And so as you're doing things, if you're getting into a lot of heavy graphics or need to access a lot of platform-specific functionality, maybe native is the way to go. But again, you've got to, if you have to target both platforms, if you're going to go native, you're going to have to build out two teams or have an experienced team that can build both. But also your designs you have to work with as well. So there's a lot of overhead by doing pure native, but sometimes there is a need for that. But with cross-platform, there's different ways to put it together. So if we look at the early days, was done with a WebView. Okay, so the idea is that you still wrote JavaScript, HTML, and CSS. This was not using a web page that you would go and browse to. This is actually bundling on the device and putting into the app stores the actual application. So your logic and everything, if you've come from web development, made sense. It was very easy. You actually wrote HTML, CSS, and you had this concept of plugins that allowed you to access specific APIs of the system. So there's several different applications that are out there that still do WebView. If you're doing a lot of very basic business applications, they're very good at that. One of the popular frameworks for doing WebViews based development for cross-platform is Ionic. They're one of the popular ones, and underneath they're using the Cordova foundation to actually set this up and work with that. But it's basically the thing to remember, it is a web page, but it's a web page that's bundled in that. And it'll be interesting to see how things evolve as the technology evolves. So challenges sometimes people in the early stages was a lot of the animation, if you're doing a lot of things that are specific and complex animations, sometimes that bridging that gap. So again, you're writing in JavaScript and you're just using the web view. Sometimes more complicated screens is a little more challenging to do that. But again, people coming from a web development background will actually easily gravitate to this because it's very easy to put an application together. Another player that's out there is Xamarin. Xamarin is actually a Microsoft product. They bought them in 2017. If you research the web, there's a framework called MonoTouch, which was the early stages before Microsoft bought them. And what they do is they actually take the .NET framework and provide wrappers around all the native API calls. So when you're dealing with developing for iOS, you can actually almost use the iOS documentation to kind of figure out how to do that. And when they initially launched with Xamarin, they were doing native UI. So that what would happen is they would wrap the native Android APIs, and they would do the native iOS native UI components, and they would wrap with C#. So you would actually only be able to share about all your business logic in the network. Your UI you would not be able to share. From there, they actually developed the Xamarin Forms, which is using XAML. So if you're coming from a Microsoft desktop background, you're familiar with WPF, Windows Presentation Foundation, it was an easy fit. A lot of enterprises that are Microsoft shops actually use Xamarin. But one of the things is it's focusing strictly, mainly on mobile development. I've used it in the past. It was worked for a Microsoft shop, so that was one that we use. But again, if you're a Microsoft-only shop, people would gravitate to this framework as well. The bigger player that actually came out was Facebook, initially with React. So React for the web kind of changed things of how you build your UI. So instead of extensioning an object that represented your UI component and directly manipulating that, they were getting into these pseudo-declarative UI frameworks. So the idea is you're declaring what your UI should look like, but the framework itself would do the actual building out the UI, and you would change your declaration of the UI to manipulate the UI itself. So you weren't really directly interacting with the actual component that represented the UI. You were making changes and the framework would rebuild and send those changes across. Now, with React Native, they took that functionality from the web side and brought it to the mobile platform, where you declare what your UI wants to look like. In JavaScript, there is this concept of this bridge that sends that declaration, and then the native component that your JavaScript declaration represents, so like a button. So a button would then translate to on iOS, an iOS button, in Android, an activity, or if it's a view, it's an iOS view. So it was actually, you're declaring something, but you're translating it into a native component. And then that's written onto the canvas and managing the event. The bridge itself is a complex piece of software. It actually handles dealing with not only the UI, but also interacting with services. So with the WebViews, you had a plugin. Here, the bridge helps with actually communicating with that. But the key to remember here is when we talk about going into other frameworks, is that you're using the actual component of the platform to draw. And that's the real thing I'll bring about in the next couple of slides when we talk about how Flutter is different, because we don't use the actual platform component. Okay, and a lot of people who use React Native came from using React for the web, so their thought process is it's very similar. So you do have JSX as you define your UI in the website. You're using DOM elements to do that, but when you start using React Native, you're importing a package that actually represents those wrappers around the native component. So a text field for the website is different than what's in React Native, okay? They did provide a mechanism to kind of use a pseudo styling that looks like CSS, but is a JavaScript object. So some of the text, The wording is similar. So a lot of people who are using React went to React Native right away. So there are some challenges that people have had over the years. So again, the JavaScript language is still there. They've run into problems where they've actually built, they were using JS Core that's native to Android and to iOS. They were actually starting to use Hermes, which is a new JavaScript compiler, to be able to get fundamental same performance across the different platforms. But again, you are declaring stuff in JavaScript, and then you're translating it to that native side and using the native components. So your animation, you declare it in JavaScript, it gets passed across. The challenge you have to be aware of when using React Native is that bridge, when you're bouncing back and forth in communications, trying to do 60 frames a second, you want to make sure that you're aware of how the framework works, because bouncing back and forth to get business logic out of JavaScript while you're having your animation running can be challenging and can be choppy in your design. So a lot of people that come from the web, they don't understand those concepts and they run into challenges right away. So the key is to actually understand the framework a little bit more before you start doing more complex stuff with React Native. So as we transition from this screen, I want you to take a look at it where on the platform side, we have these OEM particular UI components, and then you have the canvas and the event. How Flutter works differently is they've taken the need to use the actual platform components, and all they do on the platform is use the canvas and the event system. Okay. So what happens is they pull the UI of how to design the UI and all that and put that into the actual framework. So when you write your application, you write it in Dart, and we'll talk about the Dart language a little bit more, but you use this library called Skia. And we'll talk more about Skia and what that does. But what Skia does is define what the UI is, okay, and just uses the canvas like painting and drawing onto the platform. This gives a couple of benefits. Is one, you don't run into the problems where if you define something and trying to do cross-platform, when I define a visual aspect on one platform, it slightly changes. So if you look back with React Native, when we define a button, the button looks different on iOS than it does on Android. And that causes problems with styling and so forth that you have to work with. With Flutter, all that is done within the Skia framework, and the canvas is used just to draw. So now you have consistency where you can actually have an application that looks exactly the same on Android and iOS. Now, some companies, they don't want to do that. They want to have specifics, designs for each platform, such as on iOS, you have the Cupertino style. With Android, you have Material. So some companies don't want to do that. You do have the ability within Flutter, we'll talk about that, where you can actually have a look and feel of iOS and a look and feel of an Android device for those platforms. And that's all done because of the Skia framework itself. We also support, again, not every cross-platform framework is going to have all the functionality you need. So you have the ability to actually communicate directly to native services like the GPS. And again, the WebView, React Native, they all provide this mechanism. Xamarin provided it as well. The difference, and one of the things that really drawed me to Flutter was this mechanism of channels made it so easy to interact with native libraries on the platforms. And that's one of the big things that you see a lot of companies are gravitating to it when they have to do a mixture in a cross-platform framework where they're writing a lot of code and some of it's still native. Flutter actually feels like a better fit and a more robust environment. But again, you can do that with WebViews. It's a different structure that you work with. Same thing with React Native, but I found that the Flutter way was a little bit easier to work with. So let's talk about it. And we can check with on the Skia. Let me just double check to see if anybody's waiting in the waiting room. I saw your comment there. I don't see anybody popping up on my screen, Raj.
Okay, thank you.
Right.
I already checked Facebook and other channels, so I think people are also watching from other channels.
Okay.
Thank you.
All right. So with that, let's talk about Skia. Okay, so Skia is a 2D graphics library. It was purchased by Google a while back. It's used in several different places, in several different applications, as you can see from this list. And actually, there is a Skia Sharp version for people who are coming from Xamarin background where you can actually do that. So it's pretty much a graphics drawing library. And the key that the benefit it has is that it supports all the platforms, Mac OS, web, not web, but Mac OS, iOS, Windows, Android, Linux. So you can actually have this library. And this is why Flutter is using this framework itself. So the way the Flutter framework itself works is it's in layers, okay? And it's key for those layers because as you change from platform to platform, you want to be able to pull out that specific piece and put in the native code that you need. So what happens is when we talk about Skia, Skia actually runs in what they call the engine. So the embedder, which is at the bottom, that's platform specific. So if you're on iOS, it's written in Objective-C. For Android, it's Java. And then for desktop, there's C++ based coding in there. And that's specific to the platforms. Then the engine does a lot of the translation. So this is where the Skia library comes into play and handles communication to drawing out onto the native platform. The framework above, this is where all your work, when you deal with Flutter, this is most of where your work is done. You really don't get into the engine, you don't get into the embedder, you can, but you have all your work that you work on, you work within the Dart framework itself, which is at the top level. So if we look at that, it's coming down in different layers as well. At the very bottom is the foundation. There's a package called Dart UI. It has all the code that communicates with Skia, and it handles things such as animation, painting, and gestures. So all that functionality is done below that and communicating. You can actually get down to that level within the framework. You can actually paint out and draw your lines and directly with foundation calls, writing it in Dart itself. But most of the time, you're working a little bit higher up in the framework. The rendering piece actually deals with communicating with the foundation to render it. It's kind of an abstract layer. Most of what you work on is with a widget. So when people talk about Flutter, Flutter is always they talk about everything's a widget. So widgets can be a text field, but they also can be styles. So where React Native does like a CSS styling for styling the actual component, with Flutter, what happens is they have a widget that does styling on it. So it's the challenge with learning Flutter as a framework is just the vast amount of widgets that are out there. But the documentation that's on flutter.dev is quite robust and very easy to work with and is very well detailed, as well as there's a lot of training videos that are out there that cover that. Now, when you want to get to specific designs, there are two additional packages that are out there. There's the material design that uses the material design that Google provides with Android using the widget layer to draw it out. You also have, if you want to do more Cupertino-based styling, you can do that for iOS, and they have widgets for that. Now, the thing that's interesting is you can actually design something that looks like a material-based application and run it on iOS. You can actually go further and run it on desktop and web, and we'll talk about that in a minute. But you also can get something where I've played around with the styling something that looks like an iOS app and actually have it run on Android. So you have that capability of doing that. But most of the time when people develop with Flutter, a lot of times they're using the material style, and they're doing both platforms in that design. But you do have the ability to do both. So let's get into what a widget kind of looks like, give you a little example of what some of the coding looks like. It's a tree structure. So again, if you're coming from the React world, you're familiar with the rendering method. Here you have what we call a build method. So what we do is, again, we declare. We're not really building out the actual component. We're declaring what the UI should look like. And when you want to do things like change or do animations, you're actually changing your declaration of the UI, and then the framework handles drawing it out onto that. So you're abstracting away from that. And that's where, and it's not only just React Native and React that does that, Flutter does that, but also if you're up on Apple with Apple, their Swift UI, where they're doing the similar thing. They're doing a declarative framework to allow you to write across all the other Apple specific platforms. So it's not there for Android, but you have Swift UI that you can run, and you can write something that one way and have it run on Mac OS or iOS or even on Apple TV. So that move to be more of a declarative UI and have that framework do all the heavy plumbing for you is becoming more and more popular. So with that, we have, again, widgets. So there's a widget called a scaffold that helps you do a page layout. There's a widget that does centering that has no visual aspect, but actually helps you center the components. You have a column that allows you to stack together several different widgets in a column view. So that's the challenge with coming to Flutter and getting it. It's just familiar. If you're coming from the web, and a lot of people will gravitate to React Native if they're coming for React because they're familiar with the framework. Flutter is slightly different where you have a lot of widgets, but I find once you get through over that hump of understanding the widgets and get comfortable with them, it actually, your development really starts happening a lot rapidly, a lot quicker. And I found that over the years where I've taken React Native developers and switched them over to Flutter, but then given them the choice of which way they want to do for development, they actually stay with Flutter itself. And we'll talk about why, because it's not just how you lay out the components, it's actually what the framework does itself. So when you talk about Flutter, you have to talk about the Dart language, okay? Flutter uses Dart. It's not supporting other languages. Dart's been around since 2011. Google developed it where they took the things that they loved about JavaScript, but added some of the stronger things that people missed in a language. So it's object-oriented, it's type-safe. The key is at the very bottom as we talk about the just-in-time and the AOT. So when you're building an application, and you're creating it on the fly, you don't want to have to go through this complex build process to make a change and see it visually show up on your simulator or Android emulator or your actual device. You want to be able to do that practically in real time. So the benefit of using Dart is that Dart initially was designed for the web, just in time, so that as you're writing code, you can have hot reload and hot restart happen. So hot reload means I make a change and I save that file. The supporting development tools realize there's a change and they represent that change very quickly on the screen. A hot restart is sometimes when you make a change and we get into state management where it doesn't sense that change, and you can do a hot restart that actually starts you back to the beginning of the flow of your application. But again, that itself is very quick. Okay, so it's not like having to, if you've done some native iOS development where you created your layout and then you had to compile it and run the application to see how it looks. That's there. With Dart is now we have just in time, so that as you make changes, it's there. Now, when you go to run the application in production, you don't want to have it just in time component. You want it ahead of time. You want to be able to take it to bring it to machine code. And that's what Dart allows you to do. Initially, it was designed for just in time. Then over the years, they played around with trying to get it for compiling down to machine code, and they actually found that it worked quite well. Now, the thing to realize is we're not compiling it to Objective-C, we're not compiling it to Java. We're compiling it down into machine code. It's still Dart. It's still the Dart runtime language, okay? So it's still Dart, but it's now at a machine level. So your application starts up quicker. Your animation's a lot smoother because it's all running in machine at machine level, okay? So one of the things with Dart is that people are sometimes surprised is that it is single-threaded. It's you don't have multiple threads that you run with. The framework itself has a lot of multi-threading that it does in the embedder down at the C level and C++ level. But Dart itself is an event loop. It has one event loop, so as you're processing things, If you need long calls, there's async mechanisms similar to people who have come from JavaScript. You have promises. Here we call them futures within Dart that allows you to do asynchronous calls. But also if you needed to do concurrency, okay, so event loop allows you to do one task at a time, and you can do things asynchronously. But if you needed to do it concurrently, okay, Dart has the ability to do isolates. So this is not part of Flutter. This is actually part of the Dart language itself. So you have the ability to do concurrency where you can do processing. So if you have to download a large amount of data and then process that locally, you can actually create an isolate that actually will handle that processing power and then communicate back to your main isolate through messages. So you have the ability to do concurrency. It's just not multi-threaded. It's a separate memory, separate event loop structure, but you have the ability to communicate with that. And actually the Flutter framework itself, up at that top level, does that throughout the framework itself. The multi-threading is happening down below in that embedded code and in the engine itself. So the Dart framework itself is single-threaded, but they do isolates as well. Now, the Dart virtual machine, okay, the runtime of Dart is at the C level. So that's in that engine level itself. But everything above that's in the framework is written in Dart, and it's allowed to communicate with that. To do native coding, okay, we have channels. So channels allow us to write native code. And as I said before, this is one of the things that really got me hooked with Flutter, is because writing native code and interacting with the Flutter framework, I found a lot easier than dealing with how Xamarin and React Native did it. It all allows you to make calls to things that are not out there in the framework. So if you need to get GPS coordinates, you can write out to calls to the API. But at the same time, there's a repository of third-party packages that do a lot of this for you, but sometimes you may have to write native stuff yourself. But it's also not just API calls. You can actually have native UI components. So with what they call platform views, you can actually have a platform view that renders a native visual component in the framework itself. So if you use things like maps, and this is even React Native does that, when you display a map, it's actually the native platform UI components that are rendering the map and using those libraries. You're not doing it within the framework itself. So that's one of the things, if you need to do some transition when you want to move to Flutter and you have some native code, you actually have the ability to mix it. And this part of channels in the Dart framework I found in the Flutter framework really work well on that. And again, the channel mechanism, a lot of the code is in the engine, but again, you don't have to interact with that. They have a nice abstract interface in the framework level that allows you to deal with that and work with the channel mechanism itself. Now, that allows you to do that embedded deals with, okay, I have Android, I've got code that is written in Java or Kotlin. On iOS, I have Objective-C and Swift that I can interact with it. That's what that provides. But they also went further, and it's not part of Flutter, it's actually part of Dart, where they support the foreign function interface. So now you can actually write C and C++ libraries, either static or dynamic, and actually have Dart call them directly, okay? And this is where, when we get into Flutter support for the web, this is where that comes into play. So when you look at Flutter, you also have to look at Dart, but Dart itself has a lot of functionality in there. So there are frameworks that are pure Dart. There's actually Aqueduct, which is a back-end server-side version of Dart for building websites and APIs that are out there. And it's actually evolving where Flutter itself has utilized Dart, but now they have the ability, because of Dart's functionality and capabilities, they're able to expand upon that. So that kind of covers the kind of high level. And again, I wasn't expecting people to walk away and understand things, but the key to remember is the layering mechanism of Flutter allows us to handle changes and be able to easily provide plug and play with other platforms that are out there. And when you get into actually dealing with Flutter, then you have to talk about widgets and widget trees. Okay, so just like React, Native and React, it's a tree structure of widgets instead of components, and everything is a widget. So the idea is some widgets are a visual aspect, some widgets are just a layout system. And most of the time when you're developing and working with Flutter, you're in the widget tree. You're building, you're declaring what your UI should look like. And when you need to make changes, you're changing that declaration so that the framework can recognize that change and pop it out and rebuild the UI onto the actual platform. So when you talk about Flutter, though, you actually have to talk about 3 trees in the framework. So again, at that high level with the structure, we had the framework up top, we had the engine in the middle. This is all within the actual framework itself, all in pure Dart. You have the widget tree, which basically is your configuration. These widgets are immutable. You don't make changes to them, you actually recreate them. So what happens is as you're making changes into your UI, such as animation or handling a click button, that's all done. You declare it in the widget. The widget actually gets rebuilt several times through the 60 frames per second. So the widget tree is actually always kind of built and destroyed, but it's more of the configuration. So if you view the widget tree as this is where I have my configuration, the framework uses the widget tree to tell the element tree, and the element tree persists more. So the widget tree is kind of like destroyed, rebuilt, shoveled constantly all the time. The element tree has more persistence. So if you're on a screen, every time there's an element that's created, every time there's a widget that's created, there's a corresponding element. And the element tree handles things like referencing to the UI and all that. And then there's another tree, which is the render tree, and it's responsible for sizing, layouts, painting. Okay, so that gets down to that layer of the foundation and paint it out so that it can be passed on to Skia to draw it. So these 3 trees, what they do is they've isolated key aspects of what the framework needs to do so that it's easy for the developers of the framework to make changes without having large ripple effects within that. Most of the time, you're going to be pretty much in the widget tree. Sometimes you may actually interact with the element tree, and even if you don't think you are, you actually do, and I'll show you that in a minute. And then the render tree, most of the time you're not in there. You actually can build a render box directly. It's all in Dart code, and you can actually handle drawing the lines and everything. But the widget allows you to do that a lot easier. So it's an abstraction from those trees. So most of the time, again, you're going to be dealing with stuff that's a widget, but you need to understand that there's an element tree and a render tree and get a little sense that they all play different parts of the framework itself. Okay, but that's all, again, written in Dart. So when we draw a widget, okay, we actually populate a tree and it has a hierarchy. There's a corresponding element to each of those widgets. And as I said, the widget tree is rebuilt. So if you make a change so that when the user clicks a button, they change the color of the background, well, that causes the widget to be rebuilt. The widget tree gets rebuilt. The element tree has a reference back to that widget. So the framework is responsible for making sure that the element knows about the reference to the widget. And the way that it does that is through the type. So it knows that, hey, this is a text field, this element represents text. If it runs into some types of problems where sometimes complex animations, we have helper mechanisms called a key that you can actually help the element map back to the right widget. But what happens is the widget gets rebuilt, the widget tree gets rebuilt. The elements look at the widget, look at the change, and decide, is this a change that needs to be propagated out to the screen? And again, this is happening 60 frames a second going through. It's very fast, very efficient, so that we're constantly redrawing the widget, rebuilding the widget tree, but the elements don't always transfer that information out to the render tree to start the redraw of a new screen. Okay, so that's the thing that you need to just be aware of, that it's all about the widget tree, okay, that you work with. Now, managing state, because state with the widget tree, if the widget tree is being destroyed and rebuilt, we can't have the state of the application on the actual widget tree. It actually is part of the element tree. And that's a key aspect that we'll get into in a minute. But the state widget itself hangs kind of off the element tree. When we're coding, it seems like it's part of the widget, but the framework itself handles all that complexity and holds that for us. Okay. So again, when we're building widgets, there are two types of widgets. There's what we call a stateless widget, okay? And part of that is there's a build context that tells you where in the element tree your widget resides. So this is actually an abstract class that actually is the element, okay? So when we're building out our components and we have to interact with state, this build context gives us that mechanism to communicate with it. Another type of widget is called the stateful widget. Okay, so the stateful widget is actually, when you deal with the stateful widget, you're dealing with two types of widgets. One is the stateful widget that's on the widget tree that's constantly being rebuilt. The other one is the actual state, and that gets handled on the element side. What this allows us to do is set properties on it. So as you get into dealing with a stateful widget, you can actually have variables that you can have on, like here we have a gesture detector that on tap will actually cause a set state. And when set state is called, it actually runs the rebuild. So this is how a stateful widget, when you change something, it actually will rebuild your widget tree that's in this structure that's in the build method, okay? Next week, I'm actually going to talk about how to structure larger applications. And a lot of times what I do is I actually shy away from using stateful widgets a lot. You can build an application that deals with a lot of state widgets, but a lot of times what I'll do is I'll get into different state management systems like the block pattern or even Redux you can work with, where most of your UI design is in stateless widgets, and you're using seldom using a lot of stateful widgets. So that's something you can do, but again, the framework supports both. But again, next week, I'll talk about how to structure a larger application and build that out. Okay. So that's kind of you building this. We've talked about this as mobile. This is how we built the widget out there. Well, now you can do it, especially now with the new version of Dart with Flutter 2.2, is in production. They now support web-based. So you can write the same Dart framework at the very top using the same widgets, the same structure, the rendering, the element tree, that's all the same. It gets transcompiled at this point to JavaScript. They are researching utilizing WebAssembly for this, but when you declare your UI, all that functionality that you're familiar with mobile is the exact same for the web. And also, it's still in beta, but it's actually pretty solid. I've used it a few times for desktop apps. You can do the same thing. Now, for desktop, again, it's the same framework at the top. The difference is that the embedder is specific to that. And on top of that, I think it's, I'm trying to remember if it's Honda. They're actually doing an embedded for their car consoles. I believe they've created an embedded for that they're going to do some research with using Flutter for their console for the cars on that. So with that, with Flutter, you have the same declarative structure. So with React and React Native, you had JSX, but you were declaring different types of visual components, where with Flutter, if you're on mobile, if you're on web, if you're on desktop, that same declarative structure is the same across all the different platforms. So you don't have to once you learn the widget structures and everything, you're not learning something new to deal with mobile or web on that. Another nice tool that really attracted me to Flutter is their dev tools. When you're dealing with mobile and even desktop and web, performance is crucial. How to do layouts, why certain things are not laying out perfectly and you want to have an inspector to be able to actually inspect the widget layout structure, they have that. You have performance fuel tools for CPU, memory, network, and even debugging, logging, managing app size. So one of the things that all cross-platform frameworks have a problem with is the app size is larger, okay? It's because what they have to do is they're abstracting a lot of the native functionality that native developers use into a framework. So they have to bundle that framework with that. So the app size is larger, they're coming down in size, and there are tools that help you actually strip out unneeded code to really get that down. But also at the same time, the devices, the memory use, availability of storage on those devices has increased. And we're not seeing people rejecting apps because of the app size as much, okay? So with that, what we have is on the Flutter itself, the tool set is very robust and very popular on that, okay? So there are some challenges. So you probably, if you've seen some articles that are out there, or some YouTubes, iOS changed from using the OpenGL for their graphics to Metal, and Flutter adopted that. And there's been some performance challenges with that, just on how shaders are cached. So shaders are a way of how, if you get into a lot of the dynamics of how to draw lines and structure that, there's been a performance problem with Flutter when 1.7 came and embraced Metal. They've improved that a little bit more with Metal, and they keep researching more options on that. So there are some challenges. Every framework has that. And as well on the app side, they have tools that actually shrink that. But the app side challenge is something that all cross-platform frameworks have it. Okay. So with that, we have just a few more minutes left. But I want to thank Raj for inviting me. Whoops, I went too far on that. And I think I just lost my last screen. Hang on one second. Let me bring it back. And there's not as much time that we have for questions, but if anybody has specific questions, feel free to ask. And let me put this back out there. So again, flutter.dev is the website that has a lot of documentation that's out there. Dart, again, is the language for the repository of code that's out there for packages. There's the pubdev, and there's several different documents that's in flutter.dev that I strongly recommend if people are interested in Flutter, getting into and reading about the architecture, dealing with how the layouts and constraints all work within the framework itself. It's very well documented out there. So with that, I think, Raj, I think we have only a few minutes, unfortunately.
Yep, thank you, Scott. It was a nice presentation with all this information. I just have one question from my side. How do you talk to the native code from within a Flutter app?
So talking to native code, you use channels. So what happens is you build, on the native side, you actually have to write code that is written in, if it's Android, it's Java or Kotlin. If it's iOS, it's Objective-C or Swift. You write kind of a basic hook into it. So it's part of that channel mechanism. You kind of wire it up, and it's actually just a couple of lines of code, which I'll actually cover in next week's presentation, where we'll actually show you what a channel mechanism works. But then you write code in the Dart side that's, again, just several small lines of code that make that call. The framework handles the communication, be able to handle types. Now, certain complex types you can't transfer, but things like numbers, strings, and maps and complex structures get a little challenging on that. But most of the time, if you look at the pub dev, there's already a bunch of cross-platform API calls for like maps for visual aspects, but also geolocation. You can actually see, and when you look at the code, because it's all in the public repo, you can look at the code. It's very little code that you have to add to your native code. So it's just a small piece that allows that hook in to allow Flutter to make that call within it. And it's an asynchronous call. So if you look at the event loop of Dart, when you actually make that call, it's asynchronous, goes on to the stack, gets called. Once it comes back, it actually comes back into the event loop after the queuing. So if you're familiar with how the web works with the queuing for async, it's kind of similar in that nature with that.
Yeah, that makes sense. Thanks for that clear answer, Scott. I think in the next session, we'll get more details, some advanced tools and topics we understand. And thanks again for hosting this session. And we look forward to for your next session. And from the participants, if there are any questions, please ask because we are running out of time.
Yep, and the next one will be more, we'll get into code. It'll be less of a PowerPoint presentation and getting into actually showing you a project and how that project works and kind of explaining different aspects of it.
Okay, thank you. Thank you, Scott. Thank you everyone for joining today's session. Have a great day.
Thank you. Bye.